Hi, everyone. It's great to be here. Can you hear me? Yep, good. Looks good. It's great to be here. My name is Michael Serb. I work at Convex as a software engineer. And today I want to talk about building context-augmented AI chat features into your products in practice. So I'll cover why I think it's worth building a custom AI-powered chat in this day and age, what are the options for building one, and which option should you choose? And first, let me introduce a little bit about Convex for those who are not familiar. And maybe for this audience, the best way to introduce it is to look at our documentation site. And on the left side, you kind of see the feature set that Convex has. So it has functions for running arbitrary computation on the server. It has a database for storing structured, unstructured, relational data. File storage for uploading and serving files, authentication for dealing with login, sign up, authorization, scheduling for both async scheduled jobs and cron jobs, full text search for searching the database using text, and finally vector search for searching our vector database using vectors, and I'll talk about that more later. And for those for whom that didn't mean anything, another way I describe Convex is it's kind of like a higher level AWS, in the same way that JavaScript is a higher level programming language over assembly. Convex is a higher level cloud over something like AWS. And two more analogies. Convex is a modern, truly scalable TypeScript and React-friendly Firebase. And I worked at Meta for 7 years before joining Convex. And my vision for Convex is that we will make it as easy for folks to build full stack products as it is for folks working at Meta or at Google. So why build an AI chat in this day and age of ChatGPT and Claude and Bard and Bing Chat? Why build another AI chat? Well, I think there are at least three good reasons. The first one being proximity. People's behavior is driven by convenience, and talking to an AI right in your product, in a website and app, will be more convenient than going to ChatGPT, typing something and coming back to your product. And second is control. Big LLMs have broad knowledge, and so to get a specific answer, you need to prompt them specifically. And your product can do that so that users don't have to repeat themselves. And third is context. Although ChatGPT, GPTs are great, they have a lot of knowledge from training, it's possible that they might lack specific knowledge relevant to your product, either because it didn't exist, or it wasn't public, or it wasn't important enough to show up in the training data. So providing the specific context as part of the prompt can lead to better accuracy and less hallucination. And here I have like a hypothetical example of what a more sophisticated product integration of an AI chat could look like. So imagine you go to Amazon and you say, hey, reorder the thing that I ordered 2 weeks ago, double it up. It can show you the product in line in the chat. You can go back and forth, and then you can confirm the purchase, right? So this is not really something that ChatGPT is going to do with all the products that are out there. To figure out how we can build an AI-powered chat, we actually built one for ourselves. Yeah, good. So in our doc site that I showed you before, there's this little chat button that you can talk to. So let me ask it. Oh, yes, because I am not working. I have the docs open on my screen as well. There we go. Thank you. Yeah, so in Convex, rows and records in the database are called documents. So let me ask, how can I update one field of a document, one column in one row in the database? Right, and the Convex AI bot replies that I need to use the db patch method, and it gives me a concrete example. It follows the convention that we have in our docs. So if I asked ChatGPT this, it probably wouldn't know. Convex is too new. It would probably try to infer something. It would hallucinate. It would not give the correct reply. I can expand that just to see it more clearly. OK, So that's kind of the thing that we want to build. And I think that example demonstrates the 3 reasons for building a custom chat app, right? Like the interface is right there in the docs where our users are already searching for answers. We prompted them specifically about Convex, so I didn't have to say, how do I update a document in Convex, because we already know that we're inside of Convex. And we're passing the documentation that's most relevant to the user's question to the LLM to form the answer. So we didn't just build this once, this backend once. We actually built it 3 times. So there's a new OpenAI Assistants API that is tailored to this particular use case. Secondly, we implemented this using the LangChain library that's very popular. And third, we just implemented it kind of custom on our own. So before I dive into these 3 and talk about the trade-offs, let me just cover how the system works in general. So what we need to do to get this thing working is first to ingest the data and then to serve the incoming traffic. To ingest the data, we load some data. In our case, this is the documentation pages, but it could be offline documents. It could be the source code for our product. It could be something user specific. It can be anything. Optionally, we probably want to split it up to get more semantic chunks. Otherwise, we'll just get one large document that covers a lot of things. And then for those chunks, we want to embed them. That means we want to call or get an AI model to convert, to go from text of that chunk to just an array of floating point numbers. And we can do this offline. We can do this once. We can do this before we launch. But probably we'll want to do this periodically, right? Because we are evolving our documentation. We are adding new features, and we want it to stay up to date. And then the second phase is the serving of the traffic. So we just open the chat, we send in a question. What happens then? Well, we take the question and perhaps any preceding conversation, we embed it. So we again call the model, we get another array of floating point numbers. And now that we have this array and that long list of arrays of floating point numbers, we can find the ones that are semantically the closest, or in the case of the numbers, just the ones that are closest, and that translates to semantic search. And then we can take those pieces of context and pass them to the LLM. And I think it might be more fun to see this in action as well. So here I have an instance of this backend. This is the Convex dashboard. There's a lot of stuff here, but we're gonna have 4 tables here. I'm actually interested in the documents table. And there's nothing in here, but I have all the code. I have the implementation. So I also have a function, which I called fetch single, that takes a single URL from our docs and does the first step. It loads the document, it parses it, it splits it up. So let me paste in the right URL and run the function. Right. So now I have a document in the table. And because the document is long, it's split up into 4 chunks. I could see what that looks like. Yeah, it's just like a bunch of markdown that I parsed out of the HTML of the web page. But I don't have any embeddings yet. I actually split that up into a separate step because I want to run this every now and then. So let me just run the embed all. And now we called OpenAI. We got the embeddings. We store them back in our database. And now I can do basically the same thing that I was doing before from the UI, but I'll just do it here. So you can kind of see how I can test this out. And I can ask the same question, run this function. So what this does is it creates a document for my message, and then it creates a document for the AI bot for the response. And what you're seeing here is that it gets real-time getting updated with the reply from OpenAI, from the LLM. Cool. So let me go back here. So that's how the system works in general. How can we build this? How can we make this as simple as possible to build? Well, the new OpenAI Assistants API is designed to do this. And it can actually do a good chunk of this whole flow for us. All we really need to do is we need to take our documents, or whatever context data we want, and upload it to OpenAI. And then OpenAI just gives us an API that, given the question, gives us an answer. So you might be wondering, wow, if OpenAI already has this, like, what is there for me to build? Do I even need a server? Can I just plug this to on my website and run that? Well, you quite can't. You don't want to expose your OpenAI API key. You need the API key. You don't want to expose it, so you want to store it on the server. We probably want to pre-process the data before we call OpenAI. We might want to have the LLM invoke functions on our server, right? So some of the, like the example with the Amazon page that I was showing, maybe the LLM is going to trigger some action called on our server. And for a more sophisticated experience, we might want to pull in data real time from the database, like the product data. So it's great because we don't need to worry about the chunking and vector search. And a benefit is that it might improve over time without us investing any engineering effort into it. And it does have other tools besides the context retrieval that kind of powers this example. It has code interpreter and function calling, the similar stuff that you're familiar with from ChatGPT. But it is a black box, right? The results might differ from what we're seeing. It might get worse, not better. And we cannot really build anything more sophisticated once we have the question, because we don't control how the LLM is being prompted. So we cannot create any chains there. And of course, it will be much harder to move to a different API because it's unlikely that other providers will provide just this kind of API. So for these reasons, we wanted an implementation that we control more tightly. And we use LangChain. And LangChain is actually also designed to do this. Actually, the full thing is already included in LangChain's docs. So it does, including the fetching from a website and loading of the data and the splitting and the embedding and the rest of the serving of the traffic portion. This is by far the shortest implementation of the three, especially with the Convex LangChain integration. It all runs on our backend. It talks to the LM for the embedding and for answering the question. And because LangChain abstracts all of this away from us, it makes some choices for us. So, for example, by default, it actually does something that you would kind of not expect, right? You know that OpenAI has API for having a conversation. So I can include a list of messages and it gives me the next message. Well, the default LangChain setup for this particular use case doesn't actually use a conversation as the last step. What it does is it takes the chat history and the question that's coming in, and it calls an LLM to summarize it, to get a standalone question that doesn't need the chat history. And it uses that to find the context, right? And then passes the context and that summarized question to the LLM. How well this performs really depends on how well that summarization step happened, perhaps on the question that was asked. And the LLM doesn't see the whole conversation. So I don't know how many of you are like into this drama, but LangChain is somewhat controversial, and I spent some time thinking about why it's so controversial. And I think it has two kind of opposing goals. One is it's trying to make AI development more approachable, even for people who perhaps haven't coded that much. And at the same time, it's trying to wrap and encapsulate and expose like very sophisticated AI use cases. And I think those kind of go against each other. And it means that once you're trying to do something else than what it's set up to do, it's a bit hard. It's hard to get it to do the thing that you want it to do. So like I said, it was the shortest implementation, and we got that summarization step for free. Another big upside to LangChain, reason why people use it, is because it abstracts away the individual LLM APIs. So if we wanted to switch from OpenAI to Anthropic, this would be very easy with LangChain. But it can be more complex than needed because we kind of don't control the implementation. Configuring it can be tricky. And since we're writing our backend in TypeScript, we like the types to be correct and precise. And that's sometimes not the case with LangChain's TypeScript. OK, so let's look at the last implementation. What if we want total control over it, right? And I will show just a little snippet of the implementation. So this is the second phase, really, of the implementation. It's a single function, a piece of code that that runs after I ask the question. What does it do? Well, it gets the messages for the current session. It looks at the last message. It embeds it by calling OpenAI. We then search for the embeddings that are closest to the one for the last message. We get those relevant document chunks, and we create a message for the AI chatbot where we're going to insert the answer, right? Because we're going to wait a little bit for the AI to reply. And then we call OpenAI, and here you can see that we have the prompt right here, exactly how we set it up. We can tune it however we want. We pass it the relevant documents, and we pass it the conversation, tagging which is from the user, which is from the assistant. This is all running on our server, on our backend. We can tune this code however we like. From OpenAI, we get a stream back, and then we kind of accumulate that stream into this text variable, and we write it through to the database. And how does the answer appear for the user? Well, with Convex, Convex is a reactive database, so all you do is from the client, you say, hey, what are the messages for the current session? We return them, and as the messages update, the client is being sent the updated messages, and that's how they update. So with the custom implementation, we control the whole setup. And I would argue that with a platform like Convex, the custom implementation is really hard to beat because you have the full control and flexibility to set up the system in whichever way you like, and to make it as custom and as sophisticated as you want. And it really isn't that much more difficult than the other two implementations. If you want to find out more, go to stack.convex.dev or just convex.dev and find Stack there. There's a series of 4 articles, 1 article on each of these implementations. They walk through the whole code so you can kind of compare for yourself. And there's also in each of them a link to the GitHub repo for each of them. So this is all open source. You can take it, you can play with it, you can expand it as you like. And one more thing, especially if you have a bigger team, we have a pretty generous free tier already for Convex. But if you have a bigger team, if you want more usage, you can use the promo code AICamp to get 30 days of our pro plan for free. It allows for bigger teams, more projects, more usage. Yeah. And that's it. Thanks a lot for listening. And I think Idan goes next. Oh, yeah. How much time do we have? I did not push down. Yeah, a couple minutes. You're good?
No.
Okay. Any questions?
Hey, thanks for the presentation. How can I use it in a way that it can perform things more like than, for example, a LangChain AI agent builder? Like, if I use your platform, do you what are the advanced features that you have that will enable me, for example, to build more advanced and more sophisticated AI agent?
Yeah, I would have 2 answers to that. If you're trying to build more like a live agent that kind of reacts to the world outside and takes its own actions, that's where the scheduling comes in, and also webhooks. So you could have webhooks that receive information from the outside, and you can schedule actions into the future or periodically. And the other answer is that if you build your product using the Convex database, then it's very easy to augment the AI app with the product information from the database. Yeah, I think that's it. Another question?
Yeah, based on your presentation set, you said that there's some lot of your trial for using some of the like a chat OpenAI API and then the LangChain, and then you end up with the code implementation by yourself, right? So it means that like those kind of previous trial is not getting the satisfied outcome for you, right? Then how much portion do you use for the like some generative AI by your services to understand about people's like a client's code, and how much you manually implemented? How much is the portion of it?
We don't use AI to like generate code. Our customers write code on top of Convex, kind of to use AI. This is really the only use case for AI that we have right now. And we had another like a Slack bot, which is also very interesting. That was like commenting on people's support tickets. But I think we might do more of that in the future for sure. More uses of AI internally as well. But we're right now focused on building out the backend platform.
I see. So it actually the code needs some completeness that we can trust that like AI can generate the complete code, right? And then when you're doing some experiment, we end up with saying that AI, based on this like experiment, AI cannot creating the like a complete code yet, right?
Oh yeah. So I kind of talked about the building phase of the project, but there is a big phase of evaluation, right? And kind of running this project in production. We found that the custom implementation performed best in terms of the replies that it gave to the questions, but it's definitely not something that we had a lot of time to spend to kind of tune that and optimize it. We're listening to the feedback from our users, from our community, and seeing how well the bot performs. And so far, it seems to be performing pretty well. It is using GPT-4 under the hood. One more thing I didn't talk about is if you just expose GPT-4 out there, people might just use it because that's a paid feature from OpenAI. But it's because we're providing it with specific context and we're telling it, hey, if the context doesn't give you the answer, don't answer. Right? That's another kind of thing that you might want to think about as you're building AI products. That you can't just expose an API publicly for a powerful model that actually costs us money to run. Right.
Awesome. Huge thanks to Michael. Let's give it for